Hello, my name is Jackson Warters, and I'm from the Bridgeport Regional Aquaculture Science and Technology Education Center in Connecticut. My project is optimizing desalination of industrial brine through temperature swing solvent extraction. The goal of my project is to ascertain the minimum concentration of diisopropylamine required in temperature swing solvent extraction to meet the threshold of desalination in hypersaline brine. Temperature swing solvent extraction is a form of desalination that uses an amine solvent to purify hypersaline brine into desalinated water. I am using diisopropylamine as a solvent to force salt precipitation from the solution, in which I am measuring using the X-ray fluorescence spectrometer. An X-ray fluorescence spectrometer measures the excitation levels of electrons in individual atoms and can measure the relative fluorescent units of the excitation levels to differentiate the amount of each individual element in a given sample. And the readouts of those spectrums are here on my board. What's noticeable is that in the left one, which is the 12.5% DIPA concentration one, you can tell that there's a huge gap in between the solution before and after the TSSC process occurred in the chlorine levels inside the solution, which tells me that there's a huge difference in the sodium chloride in that solution. This is compared to the no difference in the other spectrum, which is the 5% of diisopropylamine solution. And this basically shows that there is little to no difference in the salt within that solution after the TSSC process occurs. I'm using the XRF spectrometer to predict the amount of sodium chloride in the salt using a linear regression model, which is shown here. And basically how I made that was I used 4 different known concentrations of hypersaline brine, which I used a 0.2, 0.4, 0.6, and 0.8 gram per liter concentrations. Put them in the X-ray spectrometer, got the average of 3 different trials that I ran, and put them onto a scatter plot. And the regression model that formed was extremely linear, which allowed me to make accurate calculations of the amount of salt in each solution that I made. And the DIPA concentrations DIPA concentrations that I used in each solution after the TSCC process, comparatively to the salt before and after the TSCC process, are shown in this graph here, figure 6, which show a significant difference in the 12.5% and 15% DIPA concentrations compared to the 10, 7.5, and 5% DIPA concentrations. And after I ran a statistical analysis, I discovered that those were statistically significant. They had p-values of under 0.05, and the 10%, 7.5%, and 0.5% didn't. Thank you, and thank you for your consideration.